So, il valore della distanza di sicurezza da mantenere da una macchina sgombraneve in azioni è di 10 metri. Now, the question is telling us that the value of the safety distance to be maintained from those macchina sgombraneve in azioni, or let me say, the snow plug vehicles in actions that they are 10 meters, 10 meters, yes. Now, what in the first case, what is distanza di sicurezza? Distanza di sicurezza is the distance that you need to maintain from the vehicle that you are following. For example, on the screen, we are having two vehicles. We have vehicle vehicle B, and we have vehicle A. So the distance that vehicle B is maintaining from vehicle A, it is known as distanza di sicurezza. Please take note, it is vehicle B that need to maintain this distance. Now, then the next one is, they use the word macchina sgombraneve. What is macchina sgombraneve? You know, after the snowfall, there are some vehicles that we, pass in order to, clear those snow. They call them snow plow, you understand? So this type of vehicles, there are some certain distance that you need to keep from these vehicles whenever they are in action. And it is not just the vehicles that clear snow. Also, we have the vehicles that spray salt on the road after, the snowfall. They are called macchina SPARGISALE, you understand? Macchina SPARGISALE. So they spray snow, there's another word, I can't remember, that they use for it. So what happened is that they spray salt. This one, they spray salt, after, especially when immediately after the snowfall or ice, when you have ice on the road. So these type of vehicles, they go around to spray salt on top of the snow or the ice. Then we also have SGOMBRANEVE, you understand? Now, in the presence of these two vehicles, or these two types of vehicles, the distance, the minimum distance that you are supposed to maintain from them is 20 meters and not 10 meters. Therefore, we can go ahead to say that this question number 1 is falso. So it is 20 meters and not 10 meters. We said that question number 1 is falso. Now let's move to question number 2, which says, il conducente deve valutare la distanza di sicurezza anche sulla base della velocità del veicolo di cui è alla guida. Now, the question number 2 is telling us, please, I'm trying to understand if you are asking question, Sister Bridget, but I can't understand it. If you can make it clear, I would really appreciate it. So question number 2, it said, il conducente deve valutare la distanza di sicurezza anche sulla base della velocità del veicolo di cui è alla guida. What is the question telling us? That the driver of a vehicle need to also evaluate the safety distance according to the velocity of the vehicle in which this driver is driving. Which is, for example, if you look at, our screen here, you see that we are having two types of vehicle. We have the red vehicle, which I will call vehicle B, and we have let's say ash color vehicle, which I will call vehicle A. You understand? Now, between these two vehicles, you can see that there is a distance, between them. Now, this distance, as I said in the other question, is a distance that need to be maintained by vehicle B, which is the red vehicle. It is the red vehicle that need to, that is responsible for this distance, or that need to maintain this distance. Now, what happened, or what is that question telling us? It said this distance also depends, or it can be evaluated according to the velocity of this vehicle B. Now, I want to give us this example, and you are also going to help me out. Let's assume that vehicle B is moving on 50 kilometers per hour, 50 km per h. Now, in the comment section, for those of you that are in our a Zoom class, I believe you can be able to tell me what is the distance, or the minimum distance that vehicle B, more or less, that vehicle B should be keeping from vehicle A. please, in the comment section. Okay, so very good. Thank you for your response. I appreciate that. Now let's do it together. If vehicle B is moving at 50 kilometers per hour, then it means that this is the how to calculate it. You understand? And what we are about to calculate, it is the distance covered in 1 second by vehicle B. You understand? If vehicle B is moving in 50 kilometers per hour, I told us the other time, take the 5, cancel the first 0, take only the number that is remaining. You understand? If for example, vehicle B is moving in 5,000 meters for kilometers per hour, for example, which is not possible, but I'm making an instant. If it's moving in 5,000 meters, in 5,000, how many zeros you have? Do you have? You have 1, 2, 3, 0. Cancel the first 0, multiply the other value by 3. You understand? And don't ask me how I got 3 here, because if you want to know that, come to our Zoom class. We will explain that to you. But in order to proceed here, so 5, cancel the first 0 here. If you cancel this 0, you have 5. Multiply 5 by 3 is going to give you 15. You understand? So we said when you have 15, you can't fall below and can't fall above. For example, if we can't fall below 15, you are going to have 15. You can't fall below, you're going to have 14, you're going to have 13, you are going to have 12, and you're going to have 11. Then if you can't fall above, you're going to have 16, 17, 18, 19. You understand? So any value that fall out to be one of this number, that is what the distance that you need to keep, more or less. You understand? Circa, as they call it. You understand? Now, in this case, we're having 50 kilometers per hour, which means that if I'm going to keep a distance from this vehicle, the distance that I'm going to keep, which is from here to here, is not going to be less than 11 meters. You understand? 11 meters. You understand? Which is going to be either 11 meters, 12 meters, 13 meters, 14 meters, 15 meters, thereabout. You understand? So, but when, I'm traveling, let me say, if I'm traveling, this is vehicle A. Sorry, I mistakenly canceled that one. If I'm traveling, let's cancel this 50 now. Let's assume I'm traveling 100 kilometers per hour. If I'm traveling 100 kilometers per hour, now you see that this distance will no longer be of the same value, because if you cancel the first 0 and multiply 10 by 3, 10 times 3 is going to give you 30. You understand? Which means that if I'm going to keep a distance, 10 times 3, sorry. Oh, wait, please. 10 times 3 is going to give me 30. Then, which means that if I'm going to maintain a distance from this vehicle when I'm traveling, moving on 100 kilometers per hour, this distance is supposed to be either 30 or 29, 28, 1, 2, 3, 27, and 26. You understand? Or 31, 32, 33, 1, 2, 3, 34. You understand? So this is what the distance is supposed to be for me, the distance that I'm supposed to keep from these vehicles. Now, before we had 15, 14. So you see that the distance that we have, or that we had when we moved on 50 kilometers per hour was smaller than the one that we have now when we are moving 100 kilometers per hour. So the velocity in which I am traveling on has effect in that distance. Therefore, I need to also consider my velocity, the velocity that I'm driving on, whenever I'm keeping a safety distance from the vehicle that I'm following. In the other side, they are trying to tell you, according to the type of velocity that you are moving, make sure you evaluate this distance that you are keeping from this vehicle. So let's assume that this vehicle is 80 meters. 80 meters. And I'm moving maybe 100 kilometers per hour. It means that I need to moderate my velocity. I need to reduce my velocity in order to increase this distance, because should anything happen, this distance will not be enough for me to stop my vehicle. Definitely, I'm going to hit this vehicle. But in order to avoid that, I will have to reduce my speed in order to increase the safety distance. So the velocity in which vehicle B, as we said, or the red vehicle is moving on, need to also be evaluated, or need to be considered while evaluating the distance between vehicle A and vehicle B. And the answer to question number 2 is 0. So, il conducente deve valutare la distanza di sicurezza anche sulla base della velocità del veicolo di cui è alla guida. The answer is 0. Okay, you said, sir, how can I join the Zoom class? Please, you can do that by reaching out to me through this number that you're having here. I'm going to write it here. 388-6431-524. That is my number. You can reach out to me through this number. You can send me a WhatsApp message, or you can call me directly. You reach out to me. So that is it. Please, if I hope everything is clear in this explanation, but if reverse is the case, you can always leave your comments or your question in the comment section, because I'm reading them. Okay, so question number 3, it says, lo spazio di frenatura è quello percorso dall'inizio della frenata all'arresto del veicolo. Is it true or false? Vero or falso? What is lo spazio di frenatura? You understand? Before we proceed to explain with some images, let me try to anticipate us with this explanation. Now, if I am moving, you understand, with my vehicle, the vehicle is moving. They told us in 1 second, in 1 second, if I'm traveling 50 kilometers per hour, the velocity 50 kilometers per hour, in 1 second, I will cover a distance of about 15 meters. 15, 14, 13, we saw it just now, 16, 18, thereabouts. That is in 1 second, which means that if I'm driving, boom, I'm driving, no obstacle on the road. As I am driving, suddenly I see obstacle on the road. So immediately I sighted that obstacle. I'm still driving before I start applying brake. You see that when I sighted the obstacle, it's not the same time that I started applying the brake. So then the time that I started applying the brake to when the car now stopped, that is my spazio di frenatura, which is the time that caused me, to stop the vehicle. Spazio di frenatura, which is the time that I start to apply the brake. Boom. Then the car now stopped. Let us look at it this way. So, this is me driving this beautiful car here. Boom. And now look at this, guitarist trying to cross the road because he's rushing to a concert. Now, I am here now. I saw this guitarist, which is the pedestrian. Now, before I get to this place, where I start, applying the brake, you see that the pedestrian is already on the road. Then, getting to here, where I stop the car, You see where the pedestrian is. Therefore, the distance that I covered from here to here is what is understood to be lo spazio di arresto, which is the space that I covered in order to stop my car. You understand? Let me do it again. I was here when I sighted the obstacle. Getting to this place, I started applying the brake. At the end of the day, it took me the whole of this place to stop. So the spazio di frenatura now is from here. Sorry. It's from here to here. This is my spazio di frenatura. That is the time that it took me to stop the car. You understand? Now, what is the question saying? The question says, let's go back, please. The question says, lo spazio di frenatura è quello percorso dall'inizio della frenata all'arresto del veicolo. Now, which is to say, the brake space or the braking space is the space that you covered from the beginning of when you start applying your brake to when you were able to stop the car. And the answer is true. It is vero. You understand? Because, as I said, I saw an obstacle. You understand? When I saw an obstacle, I was still moving. Maybe it took me 1 second to even realize that that is an obstacle. You understand? Then, in that 1 second, I was still moving. Not that I saw the obstacle, then the vehicle remained. No, I was still moving. Before I decided to remove my leg from the accelerator to the brake, I covered some certain distance. You understand? Then, after covering that distance, then I started applying brake. When I now start applying brake, after some time, then the vehicle now stopped. Then, from that moment, I started applying brake. So when the vehicle now stopped, it is not as this spazio di frenatura. Then the time that it took me is known as tempo di frenatura. You understand? The time, you understand, that it took me is known as tempo di frenatura, where the space is spazio di frenatura. You understand? So the answer, as I said, is vero. Lo spazio percorso nel tempo di reazione è quello percorso dal momento della percezione di una situazione di pericolo a quello di inizio della frenata. Now, pay attention, because I already explained this one during the last question. But if you pay attention, you understand what the question is. Vero or false? Let me try to explain the question or try to translate the question. It's telling us that the reaction time, the space that you covered during the reaction time is that, space that it takes you to see the obstacle and start applying brake. Okay, so very good. Appreciate your response, but let us proceed with the explanation. So, lo spazio percorso nel tempo di reazione è quello percorso dal momento della percezione di una situazione di pericolo a quello di inizio della frenata. Now, what is this place telling us? Remember I told us the other time in that last question that here, what happened? I saw a pedestrian. This is a pedestrian, a guitarist, that is holding his guitar, running to a concert or to take the train because he's going for a concert. Now, what happened? Immediately I saw this person. You see, he's already crossing the road, but I already covered a certain distance. Then, before I start to apply the brake of the vehicle, and this distance that I covered here, from here to here, is called spazio di reazione. Now, I explained to us during one of our lesson the other time If, for example, you told me, hey, Mr. Frank, give me the bottle of water that is beside you. Now, if I don't know that this bottle of water is to my left, maybe I first of all look at it here. The bottle of water is not here. Now, look, the time that I'm spending to look for the bottle of water is called reaction time. Take note. Now, you ask me to give you a bottle of water. I'm looking for the bottle of water. Okay, now I saw the bottle of water. You see, now I already saw the bottle of water. The time that it took me to look for the bottle of water, that is the reaction time. Then the time that took me to give you the water is the time that when I grab the water and give it to you. You understand? It is the same thing as in this situation here. Reaction time is the time that took you to evaluate, that is a pedestrian trying to cross the road. Okay, let me start to apply brake. So that time that you cover trying to evaluate if that is a pedestrian or not, then you now decide, it's a pedestrian. Okay, let me stop my car because I need to give him right of way because he's moving on the pedestrian crossing. So that time is reaction time. But when you start to now apply the brake, it's called the braking space. You understand? Or the braking time. You understand? The time it takes you to stop your vehicle. Why both of them, the reaction time and the reaction space and the braking space, both of them is called totale spazio di arresto. You might come across that on your speed. So totale spazio di arresto is the time that it took me to look for the water, then plus the time that it took me to give it to you. You understand? Take note of that. Totale spazio di arresto is the time that took me, or the time it took me to look for the water. When you asked me, when you told me, Mr. Frank, give me the bottle of water beside you. I look at the left. Let's assume that it took me 1 minute to look for it. You understand? 1 minute, then and not take me 30 seconds to give it to you. That in that case, the total time that cost me to give you the bottle of water is now 1 minute 30 seconds, because I use 1 minute to look for it, then I now use 30 seconds to give it to you. It's the same thing in this situation here. The totale spazio di arresto is the time that it took you to react, that this is a pedestrian before you start applying brake. So if it takes you 1 minute to look whether this one is pedestrian, and in that 1 minute you covered 10 meters, then when you now start applying brake, your car now stop within 5 meters. Then the total space that it costs you to stop your vehicle is 10 meters plus 5 meters. That is spazio totale di arresto. You understand? So try to understand what is the spazio di reazione and spazio di frenatura. They are two different things, but the two of them made a spazio totale di arresto. So in this case now, according to the question, lo spazio percorso nel tempo di reazione è quello percorso dal momento della percezione di una situazione di pericolo a quello di inizio della frenata, and the answer is 0. Question number 5 said, il valore della distanza di sicurezza da mantenere da una macchina spanditrice di sale in azione è di 20 metri. True or false? 0 or false? If you remember, I think during the first or second question, I made mention of it that, there is a certain distance you need to respect from these two vehicles, these two categories of vehicles, which is the snowplow vehicle and the salt distribution vehicle. After the rainfall, after the snow or the ice, you see there are this, certain category or types of vehicles. They will go around spraying salt on top of that, snow or ice. You understand? To enable, friction or adherence in that road. And this type of vehicle or vehicles, you need to keep at least minimum of 20 meters distance from them. So the answer is 0. Because remember, the other question, they told us it was 10, and I said it's FASO. Here, and they said it's 20. And this one, though, they changed the type of vehicle, but remember, there are two types, SPARGISALE and SGOMBRANEVE. Two of them, the minimum distance you need to keep from them is 20 meters, you understand? And here, the answer is 0. Il valore della distanza di sicurezza da mantenere da una macchina spanditrice di sale in azione è di 20 metri. The answer is 0. Then question number 6. It said, lo spazio di frenatura diventa 16 volte maggiore se la velocità si quadruplica. True or false? The braking space becomes 16 times if the velocity quadruples. That is what the question is telling us. The braking space becomes 16 times if the velocity quadruples. Whenever you hear this word, quadruple, what comes to your mind is 4. Whenever you hear triplica, what comes to your mind is 3. Quadruple means, quadruplica means quadruple, you understand? Which is the same thing as 4. Then triplica means 3, you understand, or triplets, you understand? So whenever you hear 3 or triplica or triple, or triplets, whenever you hear triplets, what comes to your mind is 3. Then whenever you hear double, which is radopia, what comes to your mind is 2, you understand? So these are the values they always give. Now, how is it possible for you to know if what they are saying is true? Remember, whenever it quadruples, always remember this strategy. Multiply all the numbers by itself. What it gives to you, that is what the result is. Now, if you multiply 4 by 4, what are you having? Very good, thank you. Now, if you multiply 3 by 3, what are you having? If you multiply 3 by 3, you'll be having 9. Very good. Then if you multiply 2 by 2, what are you having? If you multiply 2 by 2, you are having 4. Okay, so please pay attention. On the exam day, you don't have the time to be pressing your calculator. Your calculator is not even allowed to go in. The same thing with your phone. Now, yes, 4 times 4 is easy to be 16. It's very easy. 3 times 3 is easy to be 9. 2 times 2 is easy to be 4. But exam tension can make you see 4 times 4 to be 48 if care is not taken. Now, what do you do in order to avoid exam tension? Because you don't have calculator with you. It said 4 times 4. Do your finger like this and count it 4 times. If you count it 4 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, that is 4. Count it that number of times. Let's, for example, we are having 3 times 3. It means count 3 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9. Then we are having 2 times 2. Bring out 2, count it twice. 1, 2, 3, 4. So you don't need to struggle. Even if, don't say people will say, what is this person doing? Everybody is sitting on that day. They are on their own. Anybody who fails, we have to come back. Anybody who passes, ciao. You understand? So don't be there looking for what somebody is thinking or, those kind of things. No, the exam is your own cross. You are the one to carry it on that day. So don't be ashamed to bring out your forehand and count 4 times 4, or count 3 times 3, or count 2 times 2. You understand? So that is it. Now, while doing your quiz, you will see a question that tells you that if it quadruples, it is 16. The answer is 0. That if it triples, it is 9. The answer is 0. If it doubles, it is 4. The answer is 0. Because these are the numbers. You understand? But anything, for example, if they tell you that if it quadruples, it becomes 4, it means it's FASO. they will tell you that if it triples, it becomes 3. No, it's fast, so you understand. So this is it. Now, responding to this particular question here that we have here, please permit me to cancel this right up. Responding to this question, number 6, it said, lo spazio di frenatura diventa 16 volte maggiore se la velocità si quadruplica. And the answer is vero, because if it quadruples, it means 4 times 4. 4 times 4 gives you 16, and the answer is vero. Please, if there is anything you don't understand, do not hesitate to leave your comment in the comment section. Number 7, it said, lo spazio di frenatura è indipendente dalla velocità. True or false? And please, before we proceed to explain this question and to other questions, please don't forget that you can join our Zoom class with this number that you are having here on top, which is 388-643-1524. You have 2 days of free classes, and believe me, you don't have anything to lose. And also, please, if you look at the down of the comment section, you see that you have a place to super chat. If you also want to say, let me super chat this guy to also encourage him, you are free to do that, and I appreciate you for doing so. So let us proceed to the explanation of this question number 7. He said, lo spazio di frenatura è indipendente dalla velocità. Independente, we said it means it does not depend on the velocity. So I think during the other explanation, we were able to touch this place, but let me do it like this for us to gain a profound explanation to this question. Now, please, this is A and this is B. If I'm moving, just pick one number, you understand? You don't necessarily need to name all the whole numbers. You understand when you get there. Pick one of them that is zero. If I'm moving 150 kilometers per hour, so what is the minimum distance that I need to keep? Or what is the, let me use it like this. What is the space that I need to cover in 1 second? Then the B said, if I'm moving 90 kilometers per hour, what is the minimum distance that I need to cover in 1 second? In the comment section, please. Sorry, Mr. Nonso is saying that number A is 42. Number A is 42. Okay, Sister Bridget is saying A is 42. Those are the only 2 people that are specific, because Nonso is saying B is 27, and Sister Bridget is saying B is 30, 45. And now we said 45, plus another 4 and minus another 4 is going to give you, the number. So we have 42 here, and we have 42 here, we have 45 here. The answer is correct, you understand? And here we have 27 and 30. So if we are going to multiply 9 by 3, because we cancel this 0, 9 times 3 is going to give you 27. If you're having 30 is correct. If you're having 27 is correct. If you're having, so plus 4 minus 4 is correct. Now you can see now that the velocity have influence on the distance that you cover. Because if you are traveling 100 and Sister Ebony Black, thank you for that super chat. I really appreciate it. God bless you. So if you are moving 150 kilometers per hour and I'm moving 90 kilometers per hour, it has a lot of influence in that distance that we need to cover in 1 second, which means that it is not the same safety distance that will enable you to stop your vehicle that will enable me to stop my vehicle. You understand? Therefore, depending on the velocity that you are moving on, you also need to keep the same distance that will enable you to stop your vehicle, compared to that. You understand? You can't be moving 100 kilometers per hour. You expect your vehicle to stop in 50 meters. You just want to hit somebody, which is not, what we are, expecting as a driver. That is why safety distance is very important as a driver. Lo spazio di frenatura, according to the question, it said is independent of the velocity. It is not true, because it depends on the velocity. The space or the braking space of vehicle depends on the velocity that that vehicle is driving on. So the answer is falso. Okay, so question number 8. The question number 8 says, la distanza di sicurezza deve essere di almeno 100 metri in caso di forte pioggia. True or false? Vero or falso? This is what you need to always remember. There are some factors to be evaluated when it comes to safety distance. You understand? Yes, forte pioggia, which is strong or heavy rain, is one of them. When a heavy rain is falling, you need to evaluate or increase your safety distance. When it's snowing, you need to increase your safety distance. There are so many other factors which I cannot remember of it. You understand? So, but it is not telling you that this is the value of the distance, because if it's raining and I'm moving, look at these two images here. You see that one is inside inhabited area, while the other one is. So if it's raining inside inhabited area, I'm driving 30 kilometers per hour. I will have to increase my safety distance. But if I'm driving 30 kilometers per hour, 3 times 3 is 9. Now, 9 kilometers per hour, I can decide to increase it to 15. You understand? So if I stay 15 meters from the vehicle that I'm following, I have increased the safety distance. But what happens if I'm moving in autostrada and I'm driving 100 kilometers per hour under the a heavy rain? Then 100 kilometers per hour, the normal safety distance that I'm supposed to keep there is 10 times 3, which is 30. You understand? But if I can decide to say, let me keep 40. So if I'm keeping 40, I have increased my safety distance. So it does not necessarily be or mean that you need to keep 100 meters. You can decide to keep 100 meters. Safety distance is never too long. You understand? It can only be too short, but it can never be too long. Then if you decide to keep 100 meters, it is for your own good. But it is not true that because it's raining heavily, that you need to maintain 100 meters from the vehicle that you are following. So the answer is falso. La distanza di sicurezza deve essere di almeno 100 metri in caso di forte pioggia. The answer is falso. So guys, under here, we have some questions which I will want you to figure out the answers of these questions and leave them in the comment section. And please, as I said earlier, don't forget that you can join our Zoom class where we explain this in details. And in case there is anything you don't understand, do not hesitate to leave your comment in the comment section. With this, I want to say thank you for today. I appreciate your presence, and Sister Ebony, I appreciate you once again for this super chat. Thank you so much. And every one of you that is, that you feel you can also do the same, I appreciate you. Thank you for that. So guys, this is where we're going to leave it for today. Some other time, we are going to continue from where we stopped.